This conference will now be recorded.
All right, awesome. Thank you so much, Mary Beth. Alrighty, next slide, please. Other products that are available through NOAA STAR's Ocean Color portal are near real-time products and will be available on the Knowledge Hub as well. So first up, we have chlorophyll A products. So both a chlorophyll A anomaly difference and chlorophyll A anomaly ratio derived from ocean color measurements in a similar methodology to the GeoBlue Planet product. So these are composites that are available on a daily, 8-day, and monthly basis. These could be useful in understanding short-term changes that could be related to harmful algal blooms, as well as long-term trends, as you're given the ability to go back in time and compare that to current. You can go back in time and look at previous dates. This will allow you to sort of easily identify regions of interest and areas to focus other monitoring resources. Next slide, please. So STAR also has remotely sensed suspended particulate matter, or SPM product. So suspended particles absorb and scatter light that can be detected by a satellite. And this satellite-derived SPM product can be useful when tracing currents, sediment transport modeling, and understanding the land-ocean sediment flux as that impacts coastal ecology. This product is available back to 2018 and is likewise available on a daily, 8-day, and monthly basis. Similar to the chlorophyll A anomaly product, this is also going to be migrated to the Knowledge Hub where users will be able to access it. Next slide. So the next few products are available from GeoAquaWatch, where GeoAquaWatch is the water quality focus team within Geo. These are in development and are aimed to be available later this summer, with the Knowledge Hub being able to point to access to these tools as well. So this in particular is bringing together remote sensing and in situ data sets in the Real Earth portal being developed at U Wisconsin. So here a turbidity product is generated through the multispectral instrument aboard the Sentinel-2, which is a European Space Agency satellite, which will be able to provide 20-meter spatial resolution for turbidity mapping. This portal will allow you to generate an animated time series between different time steps to show changes, as well as plot in situ grab samples as clickable points within the animation. Next slide, please. So also coming up later this summer is a Google Earth Engine global water quality tool that is a collaboration of the groups listed, so GeoAquaWatch, World Bank, Conservation International, UNESCO, and Google Earth Engine. And this product is a real-time turbidity data processing on the cloud through Google Earth Engine. This will allow you to the goal is to provide access to water quality information specifically for inland and coastal waters on demand, and will allow you to get your hands on the data that you need for the time period that you need without needing to have a lot of background knowledge in satellite acquisitions or satellite coding. This way, the tool will be accessible for the scientific community, industry, and the general public to explore and use. At this time, I'm going to pass it off to Guangming, who's going to be able to talk to you about some of the really exciting machine learning products that are currently in development for the Chesapeake Bay.
Mary Beth, can you give me the presentation?
Yes, bear with me just one moment. Takes me just a second, Guangming. Okay.
Got it. Can you see my slides?
We do. Thank you.
Okay. First, I want to talk about a future model we're going to develop using artificial intelligence to develop new chlorophyll remote sensing algorithm for satellite data for coastal waters and in future for inland waters as well. So this is a very general overview about how the current business of satellite remote sensing of chlorophyll is conducted. So when we do satellite remote sensing of chlorophyll, the signal is affected not only by what happens in water, what happens across the water-air interface, but also what happens in the atmosphere. So that's why typically when we try to derive chlorophyll concentration from satellite data, we do atmospheric correction to remove the atmospheric signal using not only satellite data but also a whole bunch of ancillary data which characterizes the sun and sensor viewing geometry as well as the atmospheric composition. And then the next stage, we use the output of this first stage to derive chlorophyll using some algorithm. So that's what we do mostly for the current business, current methods. So this presents an issue for coastal waters because the first stage atmospheric correction will remove more than 90% of the signal that's measured at the top of atmosphere by the satellite. So in the terrestrial, in the coastal waters, we have a lot of contamination from the land, terrestrial effect, which has like absorbing stuff, for example, black and brown carbon and nitrogen oxide. So these will pose a significant uncertainty to the product that's produced by the first stage, and that will give a big error for the next stage. And on top of that, when we do the chlorophyll modeling in the water, we are also having a terrestrial impact from the land, which are like colored dissolved organic matter and suspended sediment. That adds extra uncertainty to the product. And that is basically why we don't have a really good, accurate chlorophyll product for coastal waters. And what we want to do is to build a more robust algorithm resilient to these terrestrial interferences, like in the air and in the water. And also, we want to build an end-to-end approach by using the input of top of atmosphere satellite measurement and then derive chlorophyll in one single algorithm instead of doing it in two stages. Because if you have imperfect atmospheric correction, then the product you have will have large errors. Then when you do the chlorophyll retrieval, you cannot do much about the input because the atmospheric correction is no good. And also, the current algorithm is pretty much sensor specific. You need to tune the coefficients to different sensors because of the band availability is different. What we want to do is to have one single algorithm that fits all sensors. So the way we do it is going to use the satellite data as one of the input and then feed those data because this optical data is a spectral sequence. So we're going to use some kind of sequence model. For example, this one is a long short-term memory, but it doesn't have to be like this. It can be any other sequence model like the transformers, which were used for natural language processing, for example. So basically, we use a sequence model to digest those spectral sequence data, and then use not only the atmospheric correction and sensor viewing geometry data, but also a bunch of other data, for example, the land cloud effect, by including not only the pixel of concern, but also surrounding pixels as a context information when we process this spectral sequence. So that's the idea. And so this will be a very interesting algorithm to work on. I'm very excited about it, and we're also actively seeking any funding opportunities. So please let us know if you're aware of any opportunities like that. So the next, I want to talk about a model I already developed using AI for predicting hypoxia in the Chesapeake Bay. And here is the data we used. So we used basically all the data that could potentially affect the dissolved oxygen concentration in the Chesapeake Bay. And for example, we're using MODIS Aqua satellite data. We're using the VIMS from Virginia Institute of Marine Science, a lot of hydrodynamic model outputs like temperature, salinity, currents data. And we're also using the wind data, wind statistics, basically the statistical data you would use to generate a wind rose figure. And then the field data from the Chesapeake Bay was used as the kind of the label of the data, which is the sea truth data. And then using this data, we developed the model we call hypoxia. And basically, we have a time series of data up to 8 weeks before each dissolved oxygen measurement. And then we digest each time data cube with a whole bunch of convolutional neural networks and then we feed the output of this CNNs to a sequence model, and then we make a prediction of dissolved oxygen. And this is the comparison between the hypoxized results versus the current state-of-the-art, which is the CBAFS model on the left. And then the top here is the scattered plot between the predicted versus measured dissolved oxygen concentration. And the bottom here is the data points density. And the table here shows the error matrix you can compare. So basically, we believe the hypoxide model has made some improvements compared with the CBAFS model. And also, interestingly, if we look at some randomly selected stations along the main stem channel in the spring and in the summer, we noticed that the model was able to provide more realistic vertical dissolved oxygen profiles than the CBAFS model. Yeah, that's all I have. Thank you for your attention.
Great. Thank you very much, Guoming. And as you can tell, some of that was pretty technical for me, but clearly Guoming knows what he's doing and his team, and they're picking the right algorithms, they're selecting the right models, and they're using the best local information that they can. So I'm wondering, we have about 20 minutes at this point scheduled for discussion of everything that you've heard about to date. So I'm wondering, can folks maybe unmute and let us answer any questions that you may have, or ponder features.
Hi, this is Carl Friedrichs. This is great. I'm not very familiar with GoToMeeting. Is there a way to raise a hand so we don't necessarily have to interrupt?
There is not. Just, you can put in the chat, you can say, I want to make an intervention. Yeah,
Okay. Well, I want to make an intervention since I've got the floor anyway. This
Go
is
ahead,
really, really great. I'm so excited. And also the variety of people we have talking from the talk that would just happen is very deep science, but I'm happen to be my wife is Margie Freak is the one that develops the CBEF output, and so cool that that's being merged with satellite remote sensing with AI, and also the idea of using data from the top of the atmosphere instead of trying to use algorithms that are for the ocean surface. In some cases, this is just so exciting. Anyway, one of my questions was, first I want to say this is amazing stuff. Second, I was wondering, so a whole bunch of the products that I guess it was Rachel maybe was talking about, it said it had daily, weekly, and monthly products. Does that mean that there's no daily product unless there was a clear sky? Because I was confusing how you could have daily products with satellites.
Oh, that's a really great question. I can answer to the best of my knowledge. I was not involved in the development of any of these products, but from my understanding, these products are able to account for any cloud inclusion. And so if there is cloud inclusion, things like that would be filtered out. So taking that into account, if you have a really cloudy day, you might not see as much available on that day. If anyone from the team, I know Guoming might have something to say about the STAR algorithms that they're using for the chlorophyll and the SBM products that are available on that time scale.
I think, I'm not a satellite expert, but I think they're always striving for gap-free, cloud-free products, and utilizing the vast number of satellites that are in the air, flying, utilizing the realm of satellite agencies. They're trying to provide as much coverage to get to that gap-free situation so that cloud cover wouldn't matter. Yeah, Sean, please comment. And I believe there's a question for Guaming as well.
So yes, I think everyone's assessment that when clouds are present during the satellite overpass, particularly from polar orbiter satellites, which tend to only have a couple of observation times per day over a particular area, it's going to just demarcate clouds over that area. And they'll just have to wait until the next overpass. It doesn't necessarily prevent a product from being generated, but certainly the utility of the product gets decreased if clouds are present.
But if your question is more at the how often can I get data, the potential exists for daily product availability. It just depends.
Thanks. That's very helpful.
Yeah, I can
So,
add Mary Beth to that if you don't mind. From
go
NOAA
ahead,
Coastwatch,
Sasha.
yeah, from NOAA Coastwatch, there are two products that I'm aware of which uses multiple satellites. One is the VIIRS mixed, which is basically the VIIRS NPP and N20. And then there's the so-called didnt, which is more gap filled in some sense, but a coarser resolution, 9 kilometer at this point. So there are two products that Coastwatch is putting out for distribution and for free for users to explore. And there could be many more. I mean, if you look at the other sources across the world, then there's the CCI 4 kilometer. Again, that's a 3 sensor, 20-year time series. Data available from CVIVS era onwards, CVIVS, MODIS, MERIS, and VIIRS also in the mix at 4 kilometer resolution. So potentially more gap filled too. So there are multiple sources available.
Kelly, I think you had a question. Are you able to
Yeah, I
unmute?
did. I can comment on this as well. Yeah, so there is some higher resolution products as well being delivered for the Chesapeake. There are these top of atmosphere products, similar to what Guangming was talking about because of the atmosphere correction issues. They're actually developed at NOS, but being delivered through Coastwatch. So I can put a link in the chat as to where some of those strictly chlorophyll type products, not turbidity. There are also some 250 meter resolution TSS products at the East Coast node of Coastwatch. And again, they're daily, and I'm saying that with quotes because it depends on clouds and that sort of thing, but they are from, you know, the swaths go over daily. It's just a matter of whether there's a cloud in the scene or not. And then my question was actually for Guangming. The AI that you're using for the chlorophyll algorithm, are you inputting more like the Landsat Sentinel-2 style satellite products, or is it sort of a multiple sensor thing? Because we are trying to look at how to develop algal bloom products across the US, and it'd be interesting to see how you're doing that.
Shelly, great question. Eventually, we'll be able to ingest in the data from all the sensors, but we're doing this step by step. So we break it up into a smaller, more simple tasks. So first, we're going to work on the mid resolution sensors like MODIS, VIIRS, OCHI, Maris. So these are the four main sensors we're going to work on first, and then eventually we'll include those higher spatial resolution sensors like Landsat 8, Sentinel-2, and then also those in the future when the pace data is in, and then when we have start to have matchup data with pace data, then we can put pace data in as well. As I said, the way this model is going to work is going to basically just take in the spectrum. It does not. It's going to be flexible with the band availability. It will take in whatever bands is available for a given sensor. Of course, if you have more bands, the chlorophyll data is expected to have higher quality. If you have less bands, the quality will be, uncertainty will be higher, quality will be lower. But it will be one algorithm that provides all the output, that takes in all the sensors data. That's the objective.
Great, thanks.
Sure.
Thanks, Guangming. We also have a question for you from Peter Tango. He asked, is the Hypox AI work available to review in more detail on the web, or do you have publications already?
We are still, so this is the initial version of the model. We're still working on some experiments with the model because we're doing some, I think it's called ablation test by taking different parts of the model out of the model and see how the model results changes. So there's basically a lot of moving parts. It hasn't been even submitted. I haven't even started writing the paper. We're still working on it. So it's a work in progress. But the initial version of the model shows very great promise. So I presented this model in the Ocean Sciences meeting this February. So if you're interested, I can send you like a PDF of the slides.
Yeah,
Just,
thanks,
drop me an email. Yeah, thanks for the question, for your interest.
Yeah, that sounds very helpful. And just because we're looking at different ways of evaluating dissolved oxygen, and the matter of you working through the profiles and the way that you did, and those comparisons are a lot like some of the other work that we're doing to tackle that challenge in different ways. So it's interesting to see your approach, and exciting to see how well it worked. And it's a different way of tackling the problem. So always excited to understand what could be available in terms of how we make better assessments and characterize the habitats. And thank you for sharing already.
Thank you, Peter. Feel free to send me an email. We can chat offline.
Will do. Thank you.
Thank you. I do see some comments from Jesse Turner in the chat, pointing everybody to the OCCCI and Global Color 4-kilometer spatial resolution products from ESA, and also the KD490 products as well. So thank you for that. And I was wondering, Emily Smale, could you come on screen maybe? And either, I don't know if you want to put a link in the chat or maybe your email, how people can reach out to you about becoming a beta tester?
Yeah, absolutely. I'm putting my email in the chat, and then I'll also provide a link to a dashboard that Esri has put together for the indicator. And so we are partnering with them, and one of the reasons we wanted some beta testers is so that we can get feedback on the types of maps and visualizations people would like, or trends and analysis and things like that. So if anyone's interested, please let me know.
And it is becoming quite a popular product. It's generating a lot of buzz and interest, and will go a long way towards providing information for countries around the world who don't have either water quality monitoring programs set up, or are limited resources and need to optimize where they target their sampling, also for their basic requirement to report on sustainable development goals as well. We're quite privileged here in the United States to have those resources. Also, just wanted to take a moment and apologize if you see my cats coming in and out. We'll just have a special guest star today, and I hope that's not too distracting. So I also saw Steve Greb in the audience, and I wondered too, maybe if you could comment on maybe the horizon for the turbidity products.
Yeah, I did because can you hear me?
Yeah.
I did want to mention, maybe emphasize the Copernicus land product that Rachel had shown that we're ingesting now into this this data hub that the university has, the Real Earth portal, Because it's a higher resolution product than maybe some of the others that were shown here, where we've talked about, the 4K, 4 kilometer products. This Copernicus turbidity product, for example, is based on Sentinel-2, and I think they've set the resolution at 100 meters. So it's a finer resolution, and again, in areas, Chesapeake Bay, where you have these circuitous shorelines, might be able to get, finer resolution or understanding of the spatial variability of the water itself. So again, I guess stay tuned, and as we make this more easily accessible, and we're planning on putting it on our AquaWatch, the website, people can access it directly there. The programmers are working on it as we speak here. So the deadline is July 1st, so hopefully this is all up and running by then. Thanks.
Yes, fingers crossed, and we can enable access to that through the Coast Knowledge Hub as well, which we'll show you towards the end. I do see that there was a comment. Thank you, Steve. There was a comment by Kathy Wanzi. We did SAV habitat assessment using satellite data in Maryland coastal bays, using Modus Aqua data, and found median values for seasonal chlorophyll A, KD 490 for growing season better corresponded to the known submerged aquatic vegetation habitat than mean seasonal values. Okay, so she's perhaps providing recommendations on how to optimize that product. So thank you very much for that comment. Okay, does anybody else have any more questions? Or shall we just dive right into flooding? Okay, well, let me get set up here. Again, let's see if we can get started on flooding. Sean, are you out there in the world?
I am. I just can't turn on my camera. It won't let me. But that's okay. As long as people can hear me.
We hear you fine. Thank you.
I can hear you. Thank you.
Okay. So I'm going to be talking about the combination of satellite-based coastal inundation and flood products that we've been working on. A whole group of people, obviously, that have been working on this. Next slide. That I also want to just mention that this is related to another CEOS topic of CEOS Flood Group. So we're also actively working with that group. A lot of their efforts are not along coastlines, but we want to make sure that regardless of the source of flooding or inundation, that we have algorithms that can work in all those cases. So some of the things I'm going to wind up covering are VIIRS and ABI, which basically you could think of those as either a polar orbiter higher resolution optical data set, or the ABI, which is on board the geostationary, which takes routine observations, very similar to what you wind up seeing on your local weather report, where you see the clouds moving. We can also make flood products. The trouble is they're a little lower resolution than what is preferred. And then we'll also cover synthetic aperture radar, or SAR, which is we're doing a lot of development work on that to ensure that we can exploit this all-weather capacity from using microwave radars to try and understand where the floods are occurring. And we have a couple of test cases from pilot regions that I'm going to demonstrate. Next slide. So just to kind of relate over what the CEOS disasters pilot group has been working on for floods, and you'll see how that relates over to coastal inundation. Basically, we're trying to be able to combine all these types of different satellites whether they're low Earth orbiting or LEO, which is the VIIRS satellite, or geostationary, which is the ABI or SAR, and you combine them in order to be able to come up with the right information to optimize the utility of all these satellites, because they all have strengths and limitations in their capacities. So it's only through a combination of the satellites that we can achieve the most. Next slide. So here's the types of products that we're generating. We have several VIIRS flood detection algorithms. We have some that are US specific. We have some that are going into global production. Some of them are composites to be able to create as cloud gap free as possible. And then we also have synthetic aperture radar, standalone products using a combination of different satellites I've mentioned there. We have that ABI, which can do hourly composites or daily composites of products, but obviously has a limited scope as to where it can wind up seeing, which is just over mostly the US or the Western Hemisphere, nothing at higher latitudes. It also has a limited resolution. And then you also have we're creating blended products using combinations of these different satellites. Next slide. So here's an example of some of those LEO, GEO, or visible IR or near IR. Basically, you can think of these as what your eyes, the ranges of visible is the same as the range what your eyes can wind up seeing. And there's enough color differences between what occurs when you wind up seeing floods that you can actually get a better understanding of where the floods are occurring. This is an example over the Gulf Coast. And you can, by using just the VIIRS alone, you can get one understanding as to how much is flooded. But if you use it in combination with a geostationary, then suddenly you get a whole bunch of new areas that, whether it was cloudy at the time of the one LEO overpass, or it just didn't have the right angle, or maybe the flood wasn't occurring at that time. By getting these consensus products, you can actually get a much better understanding. Next slide. So I'm providing a link. It was already mentioned earlier about Real Earth. You can actually get all the VIIRS and ABI flood mapping through this test portal, through the Real Earth environment. It's going out to the National Water Center already for evaluation and utility. And we're working to try and operationalize the product so we can ensure its routine production, sustained development, and archival of all these products. Next slide. So here's an example over the Chesapeake. Obviously, that's one of our central focus areas. And you can actually see this is using the combination of LEO and GEO. There's a couple of areas that were of concern just a few days ago. It was mentioned about clouds, and you can clearly see from the gray areas that you're not going to wind up getting consistent observations all the time. That's one of the limitations of using this type of technology. It also has limited resolution for both of these satellites, so it really can't get down to street level, which is often where people want to be able to understand where the floods are occurring. Next slide. We're also taking the products, though, trying to improve the resolution. We're trying to downscale the products. Particularly VIIRS has the ability, it starts at 375 meter resolution, but we're trying to be able to make this at a much higher resolution to where you can actually get a better understanding of where the floods are occurring within a given VIIRS cell. And basically, we're doing downscaling using DEMs or digital elevation models to try and predict where we believe the flood fraction is occurring. Next slide. You can also use synthetic aperture radar, which I mentioned earlier. There's a link actually provided at remotesensing.earth that we're doing testing on this particular technology. The good thing with SAR is that it's all weather. It can actually see through the clouds. It could be actively raining while the flood is occurring, which optical satellites can't necessarily see through the clouds. And often while the floods are occurring, or a storm is present, you can't actually see where the floods are at that moment. With synthetic aperture radar, you can get around that. It also has some improved abilities to see through vegetation. Next slide. So here's an example at the Red River of the North, which is one of our test areas that we're evaluating under the CEOS flood project, along with our Canadian counterparts. This is using Sentinel-1, which is a European satellite. The blue areas that you see there are one of the signatures. We compare 2 days against each other. It's basically just a change detection algorithm that you're actually seeing a RGB. And when changes or a decrease in the amount of radar backscatter, in other words, what's coming back to the satellite occurs, you get a very strong signal as to where floods are occurring. And the reason why is microwaves are absorbed or scattered in an opposite direction from the satellite when it comes in contact with water surfaces. So it's ideal use of the application to figure out where floods are occurring. Next slide. So this is some of the 5 test zones that we're evaluating for various projects. The Red River of the North for the flood, CEOS flood, and Chesapeake Bay specifically for CEOS coast. Next slide. You can go to remotesensing.earth and utilize the information yourselves if you want to visualize it. So this is what it generally would wind up looking like if you went onto the site. If you click on a particular location, it actually shows a time series of the amount of backscatter. Anytime you see that decrease in backscatter, once again associated often with high levels of moisture or water, is when you tend to see where floods can wind up occurring. And if you look at the 2019 and 2020 in spring, as it's being pointed to, you can actually see when floods occurred, which is very common in the Red River of the North. Next slide. If we actually, we've also taken this technology and we're applying AI algorithms. We're testing a couple of different types, a random forest as well as a deep learning algorithm or a UNet algorithm to try to automatically pull out where the flood extents are. As you see, it's actually matching quite well with the RGB that we were seeing earlier of where the flood extents were occurring on this April 17th in 2019. In this case, the random forest seems to be performing slightly better than the deep learning algorithm. We're still in the process of training these algorithms, so we hope to improve performance on both of the algorithms. Next slide. And we're not the only ones working on this. We're also working with Natural Resources Canada through their emergency geomatics services, and they are also training a deep learning algorithm to work under the same area to try to be able to understand where flooded vegetation is, to detect open water, and to be able to understand how these things are the backscatter operates in under flooded conditions in urban areas as well. Next slide. So one of the things that if you look at that time series, that if you in flooding, we've looked at a couple of cases that are more inland. Well, along the coastlines, if we actually look at this case of you can actually use it to be able to detect coastline erosions as well. Next slide. If you look at the coastline, it actually you'll see it just from a sense. You can see it actually moving over time. And if you look at it from synthetic aperture radar, you can actually look at the time series and you see this decrease that's occurring in time series over just that 5-year or 6-year time period. And that's indicative of the amount of moisture or coastline inundation that's occurring. Next slide. And you can even see that over time, that you're seeing an increase in the fluctuations, which is probably a sign of more tidal activity. If we look at the same type of application over the Newport Comfort area in Virginia, you can actually see that same type of an impact happening with a decrease in backscatter over time. Next slide. So Rachel, who had spoken earlier, along with one of her counterparts that had worked here previously, Olivia Lay, had examined the amount of backscatter during Hurricane Dorian before and after. Next slide. And I'm just going to show an example of what some of her findings were. And this is over the Middle Peninsula area, or some of the rivers just north of there, where the arrows are pointing. This is a before and after. It's hard to be able to tell from this distance, but if we go to the next slide, you can really start to hone in on some of the changes, and you'll see it darkens in the after of Hurricane Dorian. And that's indicative of, once again, those floods that are occurring. Next slide. One of the things that's also interesting in use of synthetic aperture radar, at least C-band, which is the type that you're seeing here, is that while some areas darken, other areas actually became brighter. And you'll see that right around those peninsulas or islands, I should say, right in the middle of the river, became actually brighter. And that's usually the case when you wind up having heavy forests. So you actually have to develop an algorithm that not only can detect where things have decreased in backscatter, but they've also increased due to these some impacts that the forest winds up having in multiple bounces coming back to the satellite. Next slide. If you actually look at this in the as an RGB, you can start to see that those blue areas, the bright blue areas that are heavy in vegetation, show up as once again flooded areas, and then the red areas also wind up showing where there was a decrease, which was unforested areas that were also flooded. Next slide. So we are continuing to be able to work on not only the algorithms, but implementing the VIIRS and ABI into NOAA operations. We're testing these downscaling approaches to improve the utility of it for street level evaluations of flooding. We are also adding more SAR satellites to the entire ability for us to detect. We're going to be generating more historical inundation maps for frequency and validation, as well as understanding these shoreline changes that we're seeing that is part of coastal inundation or coastal erosion. And we're also going to be integrating this into the Knowledge Hub and real Earth environments so that people have greater access to the data that we're in our ongoing work. Thank you.
Okay, so that what's on the screen is a lie. We're not ready to have a 5-minute break yet. We're about to do our Q&A and discussion. So I'll stop sharing my screen right now. But Sean, I did want to ask you one question that I had. So when you said that some areas got brighter because of problems with the forest, did you mean that previously it was like a heavy leaved forest, and then after the storm, all those leaves went away, or maybe the trees toppled, and then there were changes in the reflectance that caused increased backscatter?
No, it's actually what happens as these radar microwaves come in contact with a flooded environment underneath a forested area. They tend to create what's termed double bouncing. So you can wind up having it where it bounces off of the surface water underneath the forest, and then it reflects back over to the tree, reflects back over to the water, then eventually it makes it back over to the satellite. So you wind up with this very complex increase in backscatter that makes it where it shows up brighter after a flood event than before it. But this happens just in heavy forested areas and just under this frequency of C-band. If you have an L-band, like NASA will be launching with NISAR, or what the Japanese have with ALOS, it actually has a much deeper penetration, and you don't have these double bounce effects.
Thank you for that explanation. I just am learning some things here myself. So are there any questions for Sean? Maybe either about the technology or maybe what's different than what is already available from NOAA for flooding? What's new and different about this versus what's maybe already or being used by you? Speak up.
This is Julie Herman from VIMS. The area that you're showing is tidal freshwater. And so I think it's really interesting that the forests are reacting differently from the just vegetated freshwater marshes. But my question is, since those marshes are flooded twice daily anyway, you can't see the resolution of how they reflect in between the tidal high water. So in other words, you're just looking at hurricane flooding versus non-hurricane flooding. But I'm just wondering what you would see if you could actually look at the differences from low tides to high tides.
Well, I think you've pointed to one of our challenges actually that we've we've since overcome, and that is gathering as many satellite observations as we possibly can, coming up with a better baseline of what are normal conditions, and then turning around and applying a change detection against the overall baseline. In other words, not just looking at a before and after. We've actually implemented that in the UNet and the deep learning algorithm approach. I didn't really get into that, but it's one of the things that we are working to overcome right now. So we're hoping that some of these tidal impacts are better accounted for within what would be a normal cycle of flooding versus something that would be more a true anomalous event. The other thing is that as we were looking at those changes over time, I have a feeling that things like what we were seeing in the Gulf Coast, where it went from having very little fluctuation in those areas to suddenly within the past year seeing it where it's bouncing back and forth. I think it's exactly what you're pointing to with these tidal impacts, although we haven't examined it enough to know if that's truly the source.
I think that's really interesting. You would need to speak to a wetlands expert, but I feel like there might be the potential to eventually comment or perhaps make some hypotheses about how efficient isn't the right word, but how well the forested wetlands are storing water during storm or flood. It's how they're mitigating flooding versus how the emergent wetlands are doing it. And so I feel like there's some interesting potential from that data if you can remove the tidal influence.
Thank you. Yeah, we'd love to. Obviously, I'm not an ecologist, but more of a remote sensing person, as well as a sea ice scientist, actually. But we're happy to be able to share the information with people who can make much better sense of what we're observing.
Thanks, Sean and Julie. This is Nicole. I'm just going to jump back in to give Mary Beth a facilitation break. Also, Sean, I wondered if you might tease the other product that you're working on for the oil thickness related to
Sure.
SAR.
So one of the other applications that we've developed over time is a estimation of oil extent using SAR, and this is actually a more commonly used application of synthetic aperture radar. Once again, because it can get at high resolutions as well as it's day or night, but if you have oil sitting on top of an open water body, what tends to happen is it comes up with this very dark signature as it basically acts as almost a mirror to the radar, and it reflects all the radar to not come back to the sensor. So you wind up with these really dark signals, very characteristic of a couple of things, of dealing with surface oil. And the source of these surface oil can be any number of things. It can wind up being a natural seep. It can wind up being a bilge dump. It can wind up being coming from behind a vessel that's unintentional. It can wind up being a marine spill underneath, such as what happened with Deepwater Horizon, as well as it can wind up even being of biologic source. So I think there's multiple, and we're going one step beyond that now and working with NASA and the U.S. Coast Guard at developing a algorithm that can not only measure the extent of the oil, but a relative thickness. Obviously, there are if you're looking to recover any oil that might have been spilled, the thickness can be quite important. And there's probably some differences in what the source is based on the overall thickness. So yes, we're working on this algorithm, and I don't have any slides here, but perhaps at another meeting I can present that work. You're on mute, Nicole.
Thank you, Sean. I was just saying, I do think some folks on here would be interested in that, and I wanted to make sure we identified you as also the appropriate contact for that, and since it's connected to the SAR. So when you think of synthetic aperture radar, if we could put Sean's mug up on here, I would want you to think of Sean, because he's our resident expert on that. Are there any other questions for Sean at this point? Any other?
I think I actually do have one question. Sean, could you comment on the horizon for availability of products? I know that you're still in the beta testing. Could the folks in the audience be beta testers, or is it really more of a testing site for your team and evaluating it against your standards? I'm just asking because I'm wondering if what the horizon is for the oil spill product and the SAR product or other products that are available through that Real Earth portal to be connected to the CEOS coast.
I'm happy to be able to work with the people here to be able to evaluate the data, and I really welcome that, because in our efforts to be able to test, we're working primarily with the National Water Center, as well as other people, maybe through CEOS Flood, as part of a overall testing group. And a lot of our focus has been in areas that are outside of the coastlines. And as you see, we're getting some very intriguing signals. And we have these episodic events that are related to tropical cyclones, particularly along the East Coast and Chesapeake Bay, that I think the expertise that is here can provide a whole new level of assessment of performance and application of the data that we're already generating.
Thank you. I'll also just put a shout out to the fact that when resources are short, it is incumbent upon a user group to voice their need for a data product so that it can be prioritized and executed on when meager resources are available. to prioritize that for development at NOAA. Oftentimes decisions are made, and just like when you're shopping and you see things just randomly left on the shelf, things have to randomly get left on the shelf. And so if we know that if NOAA knows, or any satellite agency for that matter that you may be able to influence, if the need is expressed from a user, then they pay attention to that. And there is a pathway for that, which we can get connected as well. And I am just letting everybody know that I have seen our Geoscience Australia folks join, and we're not ready for them yet, but I'm just grateful that they're up because it's the wee hours of the morning where they are in Australia. So hopefully they'll hang out there with us. And Nicole, I don't know, did you want to take a longer break, or what were you thinking?
Well, I think we have, so I just wanted to tease what we have coming up in the next section. So as Mary Beth just mentioned, we're going to hear about the shoreline change products that the Geoscience Australia folks have developed. But prior to that, we're going to be talking about satellite-derived bathymetry, which I know a lot of folks are interested in. We're going to have Rick Stumpf here, who is renowned for his work in this area and has a few nice pictures to show you guys for the Chesapeake. And then Mary Beth at the end is going to dive in a little bit to the Knowledge Hub itself, which is really just a portal framework that allows you to use the data that you're familiar with and that is available in your geography in order to help evaluate the data products that you're seeing and hearing about today. So I think what we're going to do is go ahead and take a break, but ask you all to be back at 2:30, which gives you 12 minutes, or maybe less. My clocks are all different times right now. So we'll give you a slightly longer break, 10 minutes, to let you stretch and use the bathroom and get a snack or coffee if you're Stephen. And then when we reconvene, Rick is going to start at 2:35. So if you want to be back here by 2:30, that'll allow us a few minutes to get situated.
Yeah, and if I'm not seeing Rick on the
yeah, he's not here yet, so
yeah, so hopefully he'll join us.
Yeah,
we might
his slides are in the presentation, so I know he plans to be here.
We might just pivot to Geoscience Australia. But anyways, take a break. Don't.
Oh, there's Rick. I just saw him, so there you go. Thanks, Rick.
Okay. So we're just taking a 10-minute break. I'll put that on the screen.
Yeah, 10-minute break. All right, that sounds
okay.
Great.
Back at 2:30 or?
Yep.
Yeah.
Okay, very good.
All right, thank you guys.
If anybody has any questions for me from a technical perspective, feel free to ask.
This conference will now be recorded.
Okay. Nicole, are you out there? Rick, are you out there?
Yes, I am.
We'll just wait for Nicole one more minute. So, oh, she was waiting on an important phone call. That might have happened. Okay, so let me, I'll just go ahead and take over temporarily in case Nicole did get that important phone call. So it's my pleasure now to introduce NOAA's Dr. Rick Stump, who is going to be presenting on satellite-derived bathymetry, which is a focus of CEOS Coast, but he's going to be presenting his work on behalf of NOAA. We hope at some point in the future it will also be a part of CEOS Coast. Go ahead, Rick.
Okay, great. Thank you very much, Mary Beth. Great to have a chance to present this and I guess talk to you a little bit afterwards. So I'm going to talk about satellite bathymetry for shallow coastal water. And our work involves there's an interest in the Coast Survey and in the Geodetic Survey in NOAA. Gretchen Imahari is actually part of the Geodetic Survey. And we have a collaborator in Spain, and their Spanish Hydrographic Office is quite interested in that. So much of the work is being done with the two of them. And do you drive this at Mary Beth, I guess? Okay. So what satellite-derived bathymetry has been used for some coral reef mapping in the past. And what we're trying to do is to expand the capability to get into water that is not perfectly clear, where it has worked best, and to come up with a method that we can get this mostly automated. There's a lot of manual labor involved, typically with selecting imagery, and a lot of that has been rather subjective. So people will look at them and squint at it and go, well, is there sun glint? Surface reflectance off it? How many waves there are there? Does the water look turbid? And and that sort of thing. There is a cookbook in the general bathymetric chart of the ocean that the International Hydrographic Office and the International Oceanographic Commission have put together in the cookbook as a way to go through this in ArcGIS. But it's laborious, and you end out still with issues with turbidity. And they quit at relative depth, which is not necessarily a problem, but the turbidity is a key part. Algorithm that I developed a number of years ago is used for that, and we're applying with that. So we're looking to try to automate most of this and make it as useful as possible with the maximum amount of information. Next slide. So just to note, this is one of the first ones we had done. It's the Pearl and Hermes Atoll out near Midway Island. Example of detail you can get. The depths here go down to about 30 meters. That is not something we could do in Chesapeake Bay, but in very clear water, you can actually retrieve those. And it's, I will note the chart you see on the left was actually star sightings, and it was off by over a kilometer. So not only did the satellite serve the purpose of providing bathymetry, more detailed bathymetry and more accurate, but also it improved the locations for anyone trying to move in the area. Much of this is people supporting Hawaiian seals, and there's marine debris removal and all sorts of things in that area. But that's an example of where it can go with corals. Next slide. So the values of satellite-derived bathymetry SDB, it's certainly good for doing reconnaissance in remote areas. It's possible to have use a nominal calibration from one area and apply it to another. It's particularly good for monitoring shoals. An example actually here, where the shoals as shown on the chart are marked by the polygons that are in black, and a satellite-derived bathymetry shows up in the color underlying it. And you can see how much several of the shoals have moved around the area. So in fact, one channel in there is being closed off, which would not be expected from the chart. So that's one key information. Storm response is another. I think anyone here who does field surveys can appreciate the logistics of getting a multi-beam out or an airborne LiDAR mission up and flying after a significant winter storm or hurricane. Can also infill on LiDAR multi-beam. Those, of course, are the standards for hydrographic surveys, but they can't cover all the information. And multi-beam you get a lot less coverage when you're in shallow water, and LiDAR also has turbidity limitations. If the water is turbid, you get less LiDAR, and that can pose an issue. And then there's mission planning. If I go on to the next one. Example here, this is up in on Nantucket Sound, and they were, the NOAA ship was planning on deploying locations, and you can see the red circle is a zone around a potential point for a ship to go. And you can see that on the original chart, that would have been deep water, perfectly fine for a ship like the Thomas Jefferson, but the shoal has moved substantially. And so it's possible to make sure you get the ship close enough safely to deploy tenders, but also to avoid actually running any risks themselves. So an example of just the planning of the mission as well. Next slide. I've not covered a lot of detail here, but the thing is we've been working through a sequence of papers and methods to get this automated processing down. We combine multiple scenes together and look for the ones that retrieve the best depth with lower turbidity water, combine those together to generate a product. This helps also reduce clouds, atmospheric haze, and sun glint as well. And we've also gone through identifying how turbidity affects the signal, and also the best atmospheric correction. Satellite sees through an atmosphere, and we're looking at blue and green light, and over 90% of the signal comes from the atmosphere. So it's very important to correct for that. So we've been going through a sequence of processes and papers to do this effort. The goal is to get rid of that transient turbidity and the other factors that will influence the results. Next slide. Example of what you might see. This is Cape Lookout in North Carolina, individual scenes, and you can make out, for example, the shoals off of Cape Lookout, Frying Pan Shoals, I believe it is, particularly on that November 27 scene. But you notice the amount of turbidity in those lower scenes. There's a lot of sediment resuspension. And even the ones on the top row, the 1127 is the clearest scene. If someone was going to use a single scene, that would be the optimal. And I'll show in a minute how that looks. But the ones next to it are pretty good, but there's still residual turbidity. That's an issue overall. So the goal is to try to get, not to pick an optimal scene, but to try to put together, assemble the data to get to the right result. If we go to the next slide. So here's a product. The top shows a bathymetry. Well, the left side is the bathymetry. From on the top, it's the November 27th, the best scene, and the bottom is a composite of multiple scenes, all done automated. And then the residual turbidity field for both of them. So you can see how on the middle panels that are on the reddish colors, there's a lot less turbidity in that overall signal. And then the depths, we've knocked down a lot of the errors. Turbidity typically produces false shoals, which is a good thing from a navigation point of view, because it's better for us to mistake it and say it's shallower than it is than to mistake and say it's deeper than it is. And typically turbidity produces this false shoaling effect. The other part is there's some LiDAR in the same season for both of these, and in 2017, and you can see the error on the right side, how much we've reduced the total error over the entire data set. Substantial reduction in error across here. There's still some trend towards underestimating the depth. You can see a long tail on the left side, but there's almost no errors over a meter, very few errors over a meter for the composite image, whereas there's substantial areas with still errors of over 2 meters if you only use a single scene. So the compositing, and it can be, we literally pick the season, just go through the images and run these in an automated process to get that composite generated. The final calibration right now is a manual calibration, but we're working on standardizing that calibration also. Next slide. Another value is change detection. This is an example of Oregon Inlet. This is before and after Hurricane Florence, and the top is actually LiDAR data. And at least one stands out is the LiDAR. It was just good fortune there happened to be a LiDAR flight just the year before Florence went through. And of course, the one after was to try to map this inlet. It's a rapidly moving inlet, and you can see more coverage with the satellite. Many of the channels did not move a lot in the on the flood tidal delta in Pamlico Sound, but I note on the change map on the right, where brown means it's shallower and the bluish colors are darker, that shoal at the entrance moves substantially. And this is an incredibly dangerous, right in that red area. You can see there's a brown line next to a bluish line, and that pattern on a change means a shoal has moved into a channel. That's a bad situation. This is a very dangerous inlet, and it's really critical to know exactly where those shoals are. So that movement was actually picked up correctly with the satellite, and that matched the airborne LiDAR. So just getting change detection alone is a useful product. Next slide. We've been working from very clear water around the East Coast, from down in Puerto Rico through the Keys, North Carolina, Nantucket Sound also. So we're going through a whole series of areas to evaluate conditions. So we're not limiting this to just say coral reef or clear water environments. We're trying to make sure we understand fully what's going on. Isabel has added some places in the Mediterranean as well to this. So this just gets the kind of scatter plots against reference data at the same time, and results are typically on the 1-to-1 line, and we have errors within generally it's less than a meter, and then approximately 10% of the depth beyond that in most areas. There are still challenges if we have residual turbidity. You can't get rid of all of it. I'm sure you can appreciate I will say, if you can't see the bottom, we can't do satellite bathymetry. So we have to see bottom sometime during the season in order to do this. Next slide. This is an example from Chesapeake Bay. They're at Mobjack Bay in the entrance to the York River. And I just put up a nautical chart. So you can see the general pattern of the shoals are visible, the channels are present, and the like. The gray is, we've identified extinction depth, that it is definitely too deep for us to retrieve depths. We are finding, we're still working on improving the extinction depth, so we have still some false retrievals in those areas, but the overall shoals, we're picking up the channels without any problem, and it is possible. We have actually calibrated these to depths. In this area, we're down to about 4 meters is the depth we're able to retrieve for this example. But the overall patterns, and anyone who knows the area, you can quickly see some of the channels and where they might be present, and some of the shoals that are of concern. Next slide. So just talking to Chesapeake Bay, as that's the interest here, I'll just reiterate, if you can't see the bottom, we can't retrieve a depth. That's, the satellite is not magical in this way. It's kind of, if you really can't see the patterns on the bottom, we're not going to be able to retrieve the information, because those photons have to get to the bottom and make it back to the satellite. The residual turbidity does affect calibration absolute depth. We are also working on corrections for residual turbidity, and we hope that within the year we will have that corrected. So a lot of the false shoaling, when we can see the bottom but we have residual turbidity, will disappear. And we're making some refinements on the extinction depth, which will improve confidence on the deeper water end as to where we are retrieving and not retrieving. And I should say it's a little complicated because it depends on both turbidity and the water depth in order to get this right. Okay, and I think the next is last slide. Yeah. So just to finish off here, my contact information, and I'll note one area, which is, I guess, an interesting problem, something called hole in the wall at the mouth of the Pianca tank. And you can see some of the shoals and channels that we're able to pick up in that environment. The narrows going into Gwynn's Island. But anyway, it's more information in the Chesapeake area that might be of interest to what we're able to pull out of the data set. So thank you very much.
Thanks, Rick. That's wonderful. I believe Kurt Smith from the Middle Peninsula Planning District Commission is on, and he was one of the people who put us on that particular location as an area of interest in light of all the dredging that they are planning to do. So you talked about the extinction depth, and what is this might be a foolish question, but what is a good extinction depth for when you're not talking about clear waters, and we know we're not in the Caribbean? What's good to hope for?
It's very much dependent on what your application is. So if you are working in an environment where 4 or 5 meters depth is adequate, that's about 15 feet, then extinction depth of 4 or 5 meters is just fine. If you're asking questions where you need 10 meters, then you're going to need a 10-meter extinction depth. And it depends very much on the application, whether you're talking shipping or modeling. And a subtle thing on this with extinction is if you're concerned primarily about shoals and channels, so you have some confidence that if you have a channel might be moving, and the channel may be deep, so we may not be able to retrieve the depth of the channel, but we can retrieve the shoulders of it. So there's different ways to look at this where it may work out very well, that you could have a lower one. Obviously, extinction depth of 1 meter or so is I don't know. Again, it may depend on the application. If you literally have a shoal that's 1 meter deep and you have a channel that's 10 meters deep, maybe that's good enough to serve the purpose. So it just keeps depending on what your application is on it. Our goal is to get it down so we have a high confidence that if we say there's a depth, it absolutely is a depth. So that reduces the need for an interpretation on part of the user. That's a key part of this, is making sure they're not having to ask us questions or reinterpret the data. That's why we're
Right.
pushing so hard to get this down as well as possible.
Great. Yeah, I think that one of the applications that was mentioned to us is for an area like this where there are a lot of dredging projects identified or the need for dredging identified, that even just having a synoptic view, you know, so that you can understand what it was like before the project and then what may have changed as a result of the dredging project. The satellites would be able to see that.
You would be able to see certainly the width of it, and as far as the dredging project, it depends on how deep it is before and after, as far as your ability to see it.
But the way the channels might change as a result of that project would be.
Yeah, that would be quite visible. Yes.
Yeah.
Yeah. It is quite apparent when channels move, as long as you're able to see into the water. That shows up very well. There's a lot more details on the inlets in North Carolina. We had a paper in Coastal Engineering on change detection, and if it's open access, so if people want to study those images more closely, they can see examples of there were shifts in there where channels moved, and you will see what's clear erosion on one side of the channel and deposition on the other side of the channel. So the channel itself, we can't tell you the absolute depth well, but that movement is quite evident.
Excellent. Thank you. I'm sorry, I was just checking in the chat here. Is there anything, Mary Beth, that we want to?
Could I ask a question?
Oh, go ahead. Yes, Julie, go ahead.
It's Julie Herman from VIMS. This is really cool. And so perhaps another time we could talk more about the idea of going further up the York. There is topobathy LiDAR down near the lower part of the York River, but as you go further up, NOAA, they're having issues with turbidity because we're interested in the shallow water bathymetry, say 2 meters or less. And I think that there's a problem as you continue further up the river and you approach the turbidity maximum. And so if you can get shallow water bathymetry in areas where the most current bathymetry is from 1911, and that's lead lines, that would be a phenomenal data set for our research. So if at some point you would like to talk about that further, I'd be very interested in that.
Okay, that would be good. Yeah, certainly would be worth it. You're talking that be worth looking at. Just a couple of observations. The satellite we're using, Sentinel-2, this can be done with many, but we use Sentinel-2 because there's an overpass every 5 days with the 2 satellites, and 10-meter resolution serves most applications. There are commercial satellites that go higher resolution, but it's a lot more work. And of course, if you don't have, and Sentinel-2 is free. There's also a non-trivial component to that as well.
Yeah, and I think we did identify a couple other locations up the York, but I don't think you had a chance to look at those yet, right?
There were 2 there, Aberdeen and Parrot Creek.
Yeah.
And one of them will work nicely, and the other one's problematic. We actually picked them both up, and I now can't remember which one they are.
Sorry, I brought it up.
I'm almost embarrassed to say I've spent a lot of time in Chesapeake Bay, and the one section I have not been in yet is between the York and the Rappahannock River. So just about every other part of the bay, and that's the one area I haven't been to. So Kurt, I'm sorry, but maybe I need to go down and visit there.
You absolutely do.
And you certainly need to go to VIMS, yes.
Yeah, well, we will definitely keep, Julie will definitely circle back with you. And anyone else, feel free to email Rick or Mary Beth or myself, or pretty much anyone from NOAA can get you where you need to go. So we'll make sure to facilitate that. Are there any other questions? I'm going to just stop talking for a second and see if anyone unmutes.
Hey, Nicole, this is Kurt. I just
Kurt.
wanted to I just wanted to compliment Rick. I think this is phenomenal. It shows a lot of promise. I do have questions about the specific creeks that I put on your radar that we're working on, and but we don't. I'm very interested in working with you moving forward, trying to learn more about if there is some tangible things we can gather on some of these small creeks. So it's promising at least to hear that Aberdeen or one of those creeks has potential. So definitely looking forward to working with you. Thanks.
Go ahead.
Let's
Rick.
work at it sometime. We can at least exchange email. I can show you some of the products or show you, get you some more that you can look at, Kurt. This would be great. Chesapeake is, as you can all appreciate, it's not the clearest water, but this is doable. And it's, I would like to say we've completely solved everything, but as I've indicated, we haven't solved, but we're going through this very quickly. So every opportunity in here gets us further to what we need to do, which means it's a benefit to you.
And Kurt, since you're on, did I characterize those applications correctly in terms of the dredging work that you have planned?
Yeah, I think we have use for several of the scenarios the examples you showed, Rick. I was envisioning how we could use that on a number of different levels. So Nicole pinpointed one of those uses, but really any kind of information you can garner using this approach, I will have utility for it one way or the other. I think it's got a lot of promise.
Well, that's got to make you feel good, Rick.
Yeah.
That's nice.
This will be good. Yeah, the goal here is to solve this as well as we can to make it as useful as possible. That's what we're aiming for. So it's not a one-off research project. We've been working on this for a few years.
Rick, one timely anecdote I could offer you is this morning I received a call from the Virginia Marine Police, who are reporting that they can barely get into one of the federally authorized channels in our region, and so there's an immediate kind of public safety need for a dredging project, but there's obviously no bathymetric data to illustrate what that specific need is. So that kind of situation arises a lot where some of these more dynamic creeks shoal rapidly, and then everybody's scrambling to look for a solution, but nobody knows what that solution needs to look like. There's no data to support it. So yeah.
Okay, that's in your area? Maybe you can pass that on through Nicole.
Sure. Yeah, let's definitely connect soon, and I'll share some of these ideas with you.
Okay.
Yeah, I just wanted to take a moment to point out that I think it is our goal. I've stated it in the chat, and I know some people have joined later, but it is our goal through this workshop to make an initial connection, get folks interested in participating in the co-development process with us in CEOS Coast. And so we envision that connection to continue. For sure over the summer. It could be longer or take a different route. We can talk about what that looks like at the conclusion of today. But that is one of our goals. And even if folks are not on this workshop today, we will have, unfortunately not the full recording, due to my error in the beginning, but we'll have a recording where you can point people to for reference if they missed something, and where our doors open for collaborators. That's all I wanted to say, Nicole. I didn't mean to step on your facilitation.
Oh no, not at all. I just thought I was just trying to track the time, and is it I didn't have the agenda open, so I didn't know what time we were passing to
Right. We're
Stephen.
we're 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 5 minutes before we're ready to start for Stephen. If there's more discussion, we can continue that. Otherwise, we're happy to start with Stephen just 5 minutes early, and maybe that gives everybody a little bit more time to chat later. Never know what's going to happen. You just let me know what you want to do.
Yeah, I'm just going to give a chance for anybody else to chime in here.
Julie, I didn't catch your last name. If you put it
It's
in the
Julie
chat.
Herman.
I
Carmen?
sent you an email already.
Okay.
I'm so excited.
By the way, I will make the chat available as well, the chat log available.
All right, I think we're good to go. Thank you so much, Rick. That was awesome.
Okay. Thank you all for having me. Bye.
Yes, thank you, Rick. All right, Stephen, you are presenter. Stephen is joining us all the way. I'm not sure where you live, Stephen. Are you in Canberra?
I am in Canberra,
Oh,
nation's capital. Not quite as big as you would imagine.
and it's
Okay,
very
so
dark, I think, where you are.
yeah, the sun hasn't
And
come
on
up.
a
I've got two,
Saturday morning, too.
indeed.
So
Yes, I've got
thank
two
you
cats
very much.
running around here that don't know what's going on. So I'll try and share my screen. Can you just let me know whether or not this is sharing correctly,
Yes,
Mary Beth?
we see it. It's not in
Beautiful.
presenter mode yet, but I
Cool.
think
Let's
you're
give it a
just
go.
one click away from that. There you go. Oh,
Awesome.
click in the upper left-hand corner. You have the option to do presenter. Yeah. Right now I'm seeing 2 slides.
How's that?
Perfect. Thank you.
Awesome.
And if you would
All right.
like, you can click the little hide button in the lower.
Oh, yep, gotcha.
You see a
Okay. Awesome.
perfect.
All right.
Thank you.
Good afternoon, everyone. Thank you for having me. My name's Steve Sago, so I'm at Geoscience Australia. So I'm part of the Coast Group with Mary Beth, and the work we're doing obviously is looking at coastline monitoring. Robbie Bishop Taylor's my partner on this. I've given him the Saturday morning off, being so early, so I'm going to present on his behalf. I've also got a few slides from Nicolai Neslin, who's probably a lot of you know, who's doing some work in this space. There's some really cool results that are a bit more tailored to Chesapeake Bay. I guess the first thing that's worth sort of, I guess, discussing in terms of where we work in is the fact that the animations aren't going to work. There you go, too early in the morning. We're working in time series data for remote sensing. So this is the Digital Earth Australia program. Essentially, it's the same as Open Data Cube, the thing that's been set up for Chesapeake Bay. So essentially, the idea is to leverage this deep time series archive of publicly available data. To be able to go back in time to do modeling, and to be able, in many cases, depending on the setup, do sort of near real-time integration of data. So to do that, obviously, you need to work on some form of high performance computing. So whether that's a cluster compute or whether increasingly is in the cloud. And this data has all been corrected to what's called analysis ready data. So it takes out that aspect of processing the data that's often need to be done on a scene by scene basis, and you can do these nice cross comparisons over time, which is what that animation is over here, which is stubbornly not going to work. So I've got a couple of animations in here, but I guess I was tempting fate by trying to put them in there. This one being another one, which is really neat, which is essentially just an easy way of saying, it's hard working in coastal areas. It's hard working in time series data when you're looking at going back over time. Now, if this animation was working, it would be flicking through and showing you a compendium of issues that you deal with as you're working through time series, whether that be cloud, whether that be in the case of coastal environments, looking at things like glint and turbidity, and that's good and bad, and depending on what you're trying to monitor. And often when you're trying to do that time series processing, you'd need to go through and manually filter out images and start to account for all these issues to try and map something accurately over time. So the challenge in doing these things automatically or semi-automated is to work out ways to deal with these issues in an automated fashion. And again, another last animation that's not going to work. Essentially what this one is showing is one of the biggest challenges working in a coastal environment, especially in Australia, well, I guess any country, is trying to deal with that issue of tides. In Australia, we've got a varying tidal regime on a continental scale. So up north, we've got this almost 8 to 10 meter tidal range in some areas. Coming down south where you've got microtidal, we've got very small tidal ranges, but we need to be able to actually account for that. If we want to do shoreline mapping at a continental scale, which we do, we need to be able to account to that. And I think the tidal range in Chesapeake Bay is I mean, it's not negligible, but a couple of meters, and that can make a lot of difference in terms of trying to account for shorelines. So how do we deal with that? So the way that we've tackled this is we've used the fact that we've got this computational platform to integrate modeling into it. So for the implementation in Australia, we're using Oregon State tidal prediction software. It enables us to go through all these observations through time and tag a tidal offset to them automatically. So you can see on the bottom left down here, we've got an example of looking through 5 years of satellite data. Each of those yellow dots might be a Landsat observation in this case. You can actually tag the tidal height under which that observation was acquired. And to be able to get some sense out of this in terms of being able to do coastline monitoring, what we've done in this implementation is taken out from that full entire imagery stack for the year. We've taken out all the images that are required within 25% of the mean sea level of the observed tidal range. And that's an interesting concept that you don't actually see with satellite imagery, especially ones that are sun synchronous. So that means it's acquired pretty much the same time each time it goes over. You don't actually see the full range of tides. So that's another reason you really do need to constrain these things. And so you end up with a stack of images that are acquired at approximately the same tidal state. And then we have a second issue working with this this open source data is that, as Rick mentioned in the last presentation, most of the really high resolution stuff like Worldview 2, quite expensive. It's just not feasible to be able to do this kind of time series analysis. So you end up having this sort of trade-off between spatial resolution, revisit, and cost and access. So we're using Landsat, and you can see here we've actually needed to develop this methodology to do sub-pixel coastline extraction, because on the right you can see with a 30-meter pixel you get quite a jagged shoreline as you would expect. But with the method we developed, we can actually use that data and extract a shoreline which is comparable to something like a Worldview 2 meter resolution. So you get a much surer, much finer resolution and a much better extraction. So the product we've ended up with is called DA Coastlines. Essentially what it enables us to do is on a number of different sort of spatial scales, we extract these shorelines and rates of coastal change back to this beginning of the archive from 1988 through to the present. So you can see you get at the top level, you get these actual shorelines. So you get from say 1988 through to, I think we've run now to 2020. We can see these shorelines where things are eroding on a very localized scale, where things are prograding. And we've actually used that at a 30-meter spacing to be able to produce rates of change as well. As you can see, you can start looking at, we're looking at erosion here about 6.1 meters per year. We've got some uncertainty bounds around that. You can also zoom out when we're interested in continental scale applications. You can zoom out and start seeing hotspots of change. And it gives you some really neat insights into these dynamic coastlines. So these are some really dynamic sort of regions up in Queensland. You've got some beautiful sort of formations here that almost look like wave breakings over time. Some of the applications, I guess, for us, it's really about, there's a lot of investment put in by different local governments and state governments to monitor the coast, and often it's by aerial photography or photogrammetry, and that's quite costly. So, for example, this is an example up here in WA, where they run that they fly that every 5 or so years. We've actually got the ability there to not only validate using this data on the left here, but also sort of infill those gaps, so you get a much richer time period to sort of analyze this coastal change. An example here, the reason we put this one up here is this sub-pixel issue that we run into. So looking at a beach, this is a standard sort of wave-driven beach on the New South Wales coast, where the change is fluctuating, and we're looking at movements that are only a couple of meters. So we wanted to see whether or not we can actually pick that up with the 30-meter satellite data. And you can see here, this grey shaded outline is actually a 30-meter pixel. And you can see based on the validation data here, we're actually picking up that sub-pixel change quite well, even with the Landsat data. So we were pretty happy with what we're doing, and this is probably one of the most validated products we've ever done. We've got almost 50,000 different measurements from across all of our state and local government providers to validate this on a continental scale. What can it do? So I guess we've put a couple of presentations together. We did this for Digital Earth Pacific a while ago, so there's some island applications, but I just wanted to step through a couple of the application spaces that we're going to be using the data, or we've had stakeholders use the data. So I guess firstly, looking at coastal change and geomorphic change, you can pick up these really neat types of periods of change, and we've got a resident geomorphologist working on our team who's using this to gain insights into a whole bunch of things around Australia. Can start looking at sort of an estuarine system. I guess I try to pick this out as a semi-parallel to Chesapeake Bay, I guess, looking at how it behaves across that that sort of estuarine bay system. You can start looking at these interactions on different beaches, and look, I'll leave the geomorphic terminology alone because that's not my area of expertise. As I said, we did some applications in the Pacific where you have this really, you don't have a lot of room to work, I guess, in terms of looking at threats of infrastructure and geomorphic change. So we can start picking up these different types of shoreline change, where they might start impacting into infrastructure. This is up in the Torres Strait, which is in Australia, just up the northern tip between Papua New Guinea. And threats to coast, so looking at coastal infrastructure again, but this is really impacts of sort of anthropogenic change and the kind of things you might put in as a coastal engineer. This is some work now as part of CEOS Coast. We're working in West Africa, and this is some of the initial results we got there. And it's really interesting to look at. And you can see here, this is in Togo, where they've put in this port development here, put in a breakwater. This is looking probably around 2012, and you see massive onshore, downshore, longshore drift has actually had this sediment accumulation, and you can see that beach building up behind this breakwater right up to now. But the interesting thing is looking down the coast, where all of this sediment budget has been starved now, and you can start seeing from about the impact of having this built, you can actually start seeing the marked erosion over the years there. And I guess in Benin, just down the coast, a little bit more of a good news story. You can see there was erosion that had been steadily progressing, coming in, looking to populated areas, putting these breakwaters here, and you can see from the coastlines that you're really starting to mitigate against that. So that's another application, looking at things, unintended and intended impacts of coastal engineering. And of course, environmental impacts. So this is up in the Northern Territory for us, looking at some of the offshore islands. Often a lot of these are in indigenous areas for us. And one of them is probably one of the densest turtle nesting regions that we have in the country. And you can see that the substantial change that happens over time as this island naturally changes. So it's good for environmental monitoring and terming, looking at habitats and seeing how those habitats are changing and what adaptation we might need for management of those. You can pick up timings of things like lagoon breaches and the implications that come from there. And I guess this all flows into what we're doing in the CEOS Coast project. So we've launched this product, and it's reasonably mature from an Australian standpoint. And what we're trying to do now is package that up in open access science and code so it can be used elsewhere. And a couple of the earlier results that I showed there, we're working with Digital Earth Africa, which is another open data cube implementation. And they've actually run this on a continental scale just recently in the last 2 weeks. So quite exciting news, but we're getting some really great results out of there. And the scale of coastal change around Africa is just mind blowing. In some areas, you've got hundreds of meters of change per year in some areas. And yeah, very interesting stuff. You can see this, an example here in Senegal, where you've got this massive coastal change happening in these highly populated areas. And obviously working a little bit with Nick, who's on the call here now at the moment, to try and get this spun up in through NOAA in Chesapeake Bay. And so we've got that package, and it's very interesting for us to see how that implements in different countries with different tidal modeling regimes, and in an open data cube context. And so Nick's supplied me with a couple of slides that he's actually done. I'll probably just, I guess, talk to this one a little bit because I've got a fair idea of what he's doing here. So he's going here using his Landsat imagery through there. He's looking at smaller coastal regions. So this is interesting to us to see when people sort of drill down into localized areas, because we're very much focused on doing continental applications. So working with partners like NOAA and people in CEOS Coast, it's really interesting to seeing what kind of local information can get pulled out. What we've tried to do also is integrate a whole bunch of new tidal modeling into the package. So we were using the OTPS code, it is open access, but the jury's out whether it's the best tidal model to be used in all locations. So what we've done is we've integrated a Python package which enables users to go through and pick any tidal model, and there's probably 3 or 4 out there that can be used. Look, if Nick is online, I'll enable him to talk to this a little bit, because obviously I don't know the work he's done here. Nick, are you online and want to say a couple of words around your work?
Hi, just a few words.
Yeah, that's fine.
Yes, we started this project very recently, less than 2 months ago, and so these results are very, very preliminary. So first, we slightly modified the algorithm which Steve and his colleagues sent us, because in the Chesapeake Bay, the coastline is highly indented, and so the algorithm based on cross-shore transects didn't work well. And so we substituted it with circular regions where we calculate the portion of land pixels and this dynamics. Next slide, please. So first, we calculated the changes in the coastline based on linear model. So, and we see that the coastal erosion may be in some areas open, like the Bethel Beach, up to 5 meters a year. In some areas, it is more accretion, like in the Pianka Tank River mouth. And next slide, please. Also, but the question is, do we can we use a linear model of changes? And so we analyzed, the goal was to detect the areas of where the changes in the coastline are more or less correlated. And so we used empirical orthogonal functions analysis. And so we demonstrate that first EOF mode, more than quarter of variability, includes all the area, and it is slowly decreasing number of land pixels in these areas. So it is slow erosion. Next slide, please. Another second mode demonstrates us also significant decrease in land, so erosion, mostly in the open areas in the more or less open areas of the bay. And the opposite process, accretion, is in the Pianka Tank, sorry, have problems with pronouncing local names, Pianka Tank River. Next slide, please. And also the third mode demonstrates us seasonal variability, which is that in the mouths of small bays, we have erosion, maximum erosion in spring from April to June, and some kind of accretion in late fall and winter, which can be explained by probably freshwater discharge, maybe ice. And so these results were obtained in last 2 days. So I would love to hear any comments and suggestions. Thank you.
Thanks, Nick. And that pretty much ties us up. So look, I'd encourage when love to answer some questions. If you have any, you can always email us directly as well too. And if Mary Beth does share these presentations, I'd encourage people to click on the little link down here. I'm not going to test fate and try and do something interactive online, but it's a bit of a story map that runs through the applications and the way that the product looks, and could be some food for thought around applications for Chesapeake Bay. But that is me. Thank you very much, Mary Beth.
Thank you, Stephen. It's just fascinating stuff, and I have promised to share your slides so that they can go through the uh, animations that you were unable to portray in the beginning, and then also to click on that story map link at the very end to give some other scenarios. And much credit as well to Nick for working in the Chesapeake Bay, because I know that was very helpful to you and your team, Stephen, to realize that that he was able to utilize your code, your source code, and get something to work, even though it had to be slightly modified for the Chesapeake. So, and that's kind of amazing to hear that. Did you say it was up to 800 meters or up to 100 meters and change in that you're finding in Africa?
In some areas, it's really insane. It's quite crazy. We thought we were
Wow.
looking at some really big areas in Australia. But yeah, so they've just run so Digital Earth Africa has now been handed over to the sort of regional authorities. So SANZA from South Africa is going to be running that program very shortly. And yeah, they've just run the continental scale version for the first time, and the next stage, I guess, is passing that out to all the regional authorities to start doing validation and capacity building within there. But yeah, it's really mind blowing. It's really quite insightful.
I do know beach renourishment and sources for beach renourishment, sand sources, is quite of interest, especially in the mid-Atlantic states, Virginia and Maryland being two of those. So I imagine the folks on the call will have questions for you, but I'm going to stop talking and let other folks ask Nick and Stephen if they have any questions. Anybody particularly interested in this product? I know some of your early responses when you registered for the workshop indicated that flooding and shoreline mapping were your number 1 and 2, tied for first place.
Mary Beth, this is Julie again. I apologize for monopolizing the conversation, but so many of these topics are just spot on for the work that we're doing. And so for this work, it's really interesting to us because for years we have used transects to look at erosion, especially in the small tributaries off of the main stems of the rivers. And so if there's a way to calculate erosion rates in those small creeks, that would help us tremendously, or just whether or not the shoreline's, retreating or accreting. But the other current topic that we've been looking at is shoreline erosion from boat wakes. And so this whole issue of, and in these smaller tributaries, you might be able to see some of the effects if you're tracking the changes in the shoreline, if you can correlate those with boat activity to see if you can say potentially something about how boat wakes are affecting the shorelines. And so there's just all kinds of applications for the work that you all are doing for a bunch of us at BIMS. So thank you very much.
Great. Yeah, look, one of the interesting developments that we're sort of looking at is to take it to a shorter time period to sort of see those more variable influences over whether they can be seasonal, see what different drivers are. At the moment, because we really are focused on doing these sort of clean shorelines, we tend to extend the period out to a year. So we're doing these annual shorelines, which gives you that annual or median position of the shoreline change over a year. being able to pick up those shorter timescale fluctuations, the aim is to maybe integrate Sentinel-2 into the data set so we have a richer data set, and then we can shorten those time periods, and maybe we can do seasonal coastlines, and who knows what different kind of influences we can pick up with that kind of work.
Okay, great. Yeah, and I'm seeing some positive things expressed in the chat as well. People are excited about this product. I did want to put a shout out for Nick. He did ask whether or not there was some available feedback for his work there on whether or not some shorelines were accreting or receding, and maybe why that was happening, either due to water level change. I can't remember exactly the specific scenario you had put forth, Nick, but he was wanting some folks that maybe are more familiar with that area to give him some feedback. And if you want to have that conversation offline with Nick, I can enable that as well. Did anybody have any ideas?
Yes. We're very interested in ground truth. So any data sets where we have, where we know is it erosion or crashing, or so to compare it with our satellite data is absolutely appreciated.
Right, so anybody who would have, say, transect data that Julie and others mentioned would be useful for you. Also, I'll just point out, Nick, I'm shocked that you used that word, ground truth, because I've been told that it strikes fear and terror in satellite research scientists, you know, globally. And so, yes, but those of us who are in the world and in this audience who are not satellite research scientists, that's a more familiar term to us.
We really do need it. I mean, to second what Nick said, I mean, one of the things that's really interesting to us, regardless of where this is applied, is how this process works coming inshore. So, you know, in these complicated estuarine systems, as you move further up river channels or into bays and things like that, whether or not the tidal model we're using is applicable going there, because generally speaking, they're better on the open ocean. So getting validation, especially in those complex estuarine systems, and as you go further up a river channel and things like that, that's really interesting to us as well too. So even if it's just observational ground truth from a sanity checking standpoint, it's really valuable.
Great. Is Nicole out there? I'm not sure. She might have had to drop off. Oh, there she is. Yeah.
No, I'm here. I had a question, Stephen. So in Australia, is this application, well, you said you had a pretty rich data set. How is the government going about monitoring shoreline change? Is it relying on the satellite-based application, or is it prioritizing, certain areas for in-person monitoring? How are they balancing that?
Yeah, so look, in Australia, most of the coastal management falls to a state-based sort of management. So the state governments are generally the custodians of that. And there's always, so we're obviously a federal government agency, and so we work closely with the states. And most of the time, their monitoring is done through physical, whether it's getting out there or doing photogrammetry, flying with aircrafts and things like that. And I guess based on the pure cost aspect of that, it's prioritized in a big way, especially for a coastline. I mean, it's similar in the US. You've got so much coastline to deal with that you just can't fly photogrammetry every year over the full coastline. So it's very highly prioritized. And that's one of the good things that doing this continental scale approach has already done with our state stakeholders, is highlighting hotspots that they might not be monitoring, that they might not be aware of, and things that, so obviously they've got hotspots that they've been aware of for decades, and they might monitor those, but other spots might be changing, and this has really started to help them. And they are using it as a prioritization type of tool. So even if we're not able to give them the sort of drill down, sub-year change thereafter, they can see that there's something happening in that environment that they mightn't be aware of, and they can use that to prioritize their resources for going out and doing further monitoring or surveying. So it's helping them to prioritize resources is I guess the main aspect, the main answer to that.
Great,
Nicole,
thank you. Yeah, I think that's what I heard from some of the folks at VIMS when we first started talking about this was I thought Donna had told me that it takes about 5 years to completely update the shoreline in Virginia. And so it's a rather long process to do all that. And I think that's why they were so excited to see this application. So thank you.
I did just want to point out, Nicole, there's quite a lot of contributions in the chat. Roger Barlow has pointed out some USGS and Maryland DEP or Department of the Environment, MDE, I guess it is, work. There was also a comment by Sean indicating that the water surface roughness and vessel detection is a component that synthetic aperture radar can contribute to as well. So for those who are interested in maybe shoreline migration, would be also interested in some other products. Synthetic aperture radar products. Roger also points out that the US GS MDE effort used 6-inch ortho imagery and QL1 topography LiDAR. So that presumably might be available for quote unquote ground truthing. I don't know. SRC asks a question. Have you considered using USGS stream gauges? Flow rates may change with the channel growing or shrinking.
Yeah, these the data integration and drivers aspect of this is really interesting. So we have had some initial trying to correlate what we're seeing with the trends both at a local and a sort of a more regional scale, with things like climate drivers, looking at events such as heavy rainfall events when we've got increased stream flow, whether or not we can start correlating any of those things back to the rates of change we're seeing, and some of the stuff that Nick had up there in terms of looking at different ways of slicing, dicing those rates of change. I'd imagine that's where that real strength would fall in, when you can start integrating and trying to look at drivers for those kind of things. So yeah, there's lots of possibilities of integration of different data sets for sure.
Great, thank you. Any other questions for Stephen before he goes back to bed or gets off for his morning run? We do want to thank you again for checking in on your Saturday morning, Stephen, to make this presentation as valuable as it could be for the Chesapeake Bay stakeholders. Although we're sure that Nick could have done a fabulous job, you are the expert. You and your team are the experts in this and can show all those fabulous relevant places that you've tested the product or are testing the product. And we certainly hope that some of the Chesapeake Bay stakeholders will actively agree to engage in the co-design, co-development process with us on your shoreline product in the Chesapeake Bay.
Great. Thanks for having me.
So,
it was great.
Yes, thanks very much. And again, I will make Stephen's presentation available for everybody that was on the call. And Nicole, is it all right with you if I just start early on the portal?
Yeah, I think you should.
So I'm just going to share my screen. Actually, I don't have the right thing up. Oh, no, I did. Okay. So what I've done is I've created a short video for you that walks through Prasanjit Dash's expertly created knowledge hub. It's a silent video that I am just going to narrate for you. I tried to make, whenever I made it, I tried to make my mouse as large as possible so that you could follow along. I'll try and point to you where I am on the screen. We can give you the link so that you guys can do your own driving around and clicking on things if you want to. This was just a quick and dirty opportunity to give you an introduction, especially for those of you who have hung in this long. We wanted to sort of show you what brings it all together, and that's Sanjit's knowledge hub for the CEOS Coast. And just wanted to take a moment to acknowledge Sanjit, if we can turn his camera on so that we can see him. Hopefully he can do that. And he'll be happy to answer any questions that you have about this whenever I'm finished. So bear with me just one moment while I try and pull this up. And I'm going to make this full screen. So I hope that this is what you're presented with when you first come on. And you can see on the left is some curated information. You can make that go away. This happens to be a list of storms. You can make it go away to give you some more space on the screen. Towards the top, you can also maximize your screen size by just popping out of that window. And then let me see, where are we now? So we wanted to show you that those legends, you can make that go away. All you need to do is just hover over that legend button there. And then this drop down here in the upper right-hand corner is where, right now we have sea surface temperature listed, but this is where you can enable all the CEOS Coast products. Here we're clicking through the ocean color, sea surface height, and then a winds product. So these are all currently available through NOAA Coast Watch. The coast products are not on here yet, but they will be. There's also some data points that you see in the green and yellow circles that you can click on and find out more information. You can certainly change the base layers, and you can change some reference layers. Here you can turn off labels, turn on coastlines and water bodies. This turns on the states. And then if you go, follow my cursor down to the bottom of the screen, hopefully you can see it. I'm not able to see it on mine, but there's an ability to, there's a date feature down there, and you can customize the dates. You can toggle through specific dates, choose a series of dates, and have that go on a loop, almost like a little video. And then in the, there's two ways to zoom in. You can use the plus or minus zoom button, or you can choose the regions drop down in the upper right-hand corner. And Sanjit has enabled kindly the Chesapeake region. Just click on that. It doesn't take you all the way into the mid-peninsula area, but we get kind of close. So then I can refine using the plus minus buttons. So here we are zooming in directly to the mid-peninsula region. Once again, in the upper right-hand corner, you'll see, well, basically on the whole right side panel, you'll see the list of curated data. So the data that's currently enabled was the damaging storms. You can also turn on harmful algal bloom data. You can add rain data. But for this demonstration, I just hid all of that. Below that, we have what's called contextual information. We have hydrology, social science, land elevation, ecological data sets, and land and sea data sets. So first, we're going to start with the hydrology. And you can turn on and off different layers. There's some dams that appear when you click on the hydro shed. When you move your cursor over that, it will highlight different watersheds. You can click on that and find out some information. And then you can click on the elevation for the land, adjust that. We're going to also add North American salt marsh data, which you'll see comes up in yellow. And once again, when you click on those features, it will show you some information about where that salt marsh data came from. So that's quite nice. Under land and sea, here we have the default is the USGS Ecological Coastal Units, which I know Prasanjit worked very hard to get integrated. It's not showing you that that's a drop-down where you can select different data sources, but I've just chosen tidal range. And the same feature is enabled here under social. That was just the human impact assessment, but under the social tab, we have the opportunity for the commercial data source, and different years are listed there. It defaults and is only showing you 2018, but there's a whole list. I think it goes back to 2012. So you can choose which parameter. I just selected storm surge. And then the year that you want to compare it as well. So now that we have selected all that information, of course, we want to know more about, what are all those colors that are now on my map. So we can re-enable the legend. Just click on the question mark at the end of each of those data sets, and that brings up the scale. You can also hover over the color, and that will provide you more information on that as well. And if you need to maximize your screen again, you can just either get rid of that legend temporarily or just move it out of the way, like I'm doing there with the data selection tool there on the right. And did just want to show you that there in the upper right-hand corner, Prasanjit has enabled a screen capture. It's a little camera. You can also make an album and save all your images there. You can get rid of some of them. We also will have an about feature and a story map feature that we're not going to go into today, or not going to demonstrate today, but we did just want to show you this video as a way to just quickly and show you what the Prasanjit's amazing Coast Knowledge Hub can do. So I just wanted to take an opportunity. I'm going to stop my screen share now and see if anybody is having questions or comments about that or anything else that we've talked about today.
Mary Beth, this is Nicole. I just wanted to remind everybody that the those data that you just went through and kind of highlighted some of the information that we think will be helpful in order to help you evaluate some of the products. So the satellite products that we saw today would ultimately land in that hub as well. And that would be a layer, an additional layer that you would be able to turn on and kind of see that in context.
Absolutely. I did go over that rather quickly. But yes, where we were able to select the sea surface temperature tool, sea surface temperature product, or the coastal winds product, the other coast data products. Those are currently served by NOAA Coast Watch. So those are just in there as examples and useful information. We didn't also go into sort of the list of storms, but there is information about all of those storms, just in case maybe your flooding event was related to the passage of a hurricane, or your seagrass die-off was related to a harmful algal bloom event. You can enable access to some additional antecedent information that will maybe help you in make your management decisions. So any comments or questions for Sanjeet? I know one of the things that was brought up was, oh no, not another portal, right? Are we going to have to learn? Are we going to have a password for this one too? And the good news is, although there is temporarily a password just while it's in the testing phase, no, this will all be free and open access. It will be as seamless. If you're used to using NOAA Coast Watch products, it will be hopefully as seamless as that. We are a work in progress, so please don't compare us to the highly efficient and customer service oriented NOAA Coast Watch.
Mary Beth, could I ask one question? So so perhaps there's a data set that we don't have in the hub that Carl Fredericks wants to use to evaluate some of the initial products we showed. So will we be able to pull that in for him?
Yeah, it's probably better asked to Prasanjit, but I mean, with all my naivete about how hard the work that he's already created was for him to do, would say enthusiastically yes, but I do think that is the goal of COAST, is to make that happen. Prasanjit, are you out there?
No, I'm here. Was there a question?
There was a question. So can Kurt's data be made available in the Knowledge Hub?
What type of data?
I was just kind of punting to you, Pras. I was basically wanted you to tell folks how, if there are data that are not currently in the hub that would be useful for evaluating one of these products, that we would be able to try to facilitate that, correct?
Yeah, my quick answer is yes, definitely. And Mary Beth, you made a good presentation about some of the map interactions, but I think the grouping is something that we need to speak about in another seminar sometime. You know how these data are organized. There are three distinct groups now. There's satellite group, there is events, there is a station data group, as well as the contextual information. And some of the data, Nicole, that you told Rachel to look for, they're already available there actually. For example, what was that, Rachel? Hydroshed? No, some kind of hydrobasin data.
Yes, so I think those were the HUC 12 units.
Right.
Yeah.
So they are all available. So essentially we have four groups, and of the four groups, there is the event listing, which will be tied to a story map for each event. And finally, we'll also have a future prediction module available. For example, the IPCC reports are based on some published literature or so. So yeah, the quick answer is sure. If it's in any standard format, we can include that based on request.
Yeah, I just wanted to make sure it was clear that the hub.
It might be helpful, Maribeth, if you just share the link and the temporary login and password. So if anybody is interested, they can explore on their own the intermediate version now. That should be okay.
Okay, I will definitely enable that in the follow-up email.
Yeah, and
Go ahead.
one more thing. When you showed those social indicator data or any other data which vary over time, there will also be a visual comparison split tool that will allow you to visually cross compare things, how things change. It's not a change detection per se, but it's more like visual change detection.
Okay, great. Thank you. So as I alluded to, I will be offering a rather substantial follow-up today, just from providing links to the video. I think that will come on Monday, because if you're anything like me, you're probably ready for the weekend to start. We do appreciate you hanging in there this long. And I think I'll turn it over to Nicole, unless she wants to punt back to me, but I think this is our final slide. And I think our goal is to just find out and maybe have a discussion about whether or not you guys are interested in meeting in for the co-design, co-development process with us. We envisioned it happening. We kind of have a report out that is due in September. So we wanted to take advantage of the summer, May, June, July, into August if necessary, to engage with stakeholders. Hopefully, if we do a great job, and you guys helped us tick some boxes, and we're just beginning to tick those boxes for sort of our first 3-year evaluation, that the green light will be given by CEOS to continue COAST, and to delve to further develop these products, delve into some new areas, like perhaps new products. Blue carbon is very popular. People keep saying that. I sometimes wonder what that means to different people who say it. But anyways, and of course, polar regions. We don't have any of those in the Chesapeake Bay, but many people are interested in polar region products. So I just wondered, I've seen at least one person in the chat indicate their enthusiastic support. Sorry, cats are showing up for guest appearances. But could we just have a 5-minute discussion about what folks think that looks like, maybe for continued engagement?
Yeah, so I'm going to ask Cersei, who works with the Chesapeake Bay Reserve in Virginia. Cersei, are there opportunities this summer for outreach and engagement that you already have on the schedule?
None on the schedule yet, but that's not to say that we can't make them. So I'm all in.
Great, thank you. Appreciate that. Are there other folks that, are there other things that we should be leveraging, or folks that, so Shelley's mentioning the Chesapeake Community Symposium. I don't think we have that on our radar just yet. When is that, Shelley?
It's in June. I'll put a link in the chat.
Okay.
I mean, I think abstracts have already been in because the registration ends this week, I think, but you might be able to get something in there.
Well, I think the outreach is really sort of, I mean, it happens, the engagement is happening simultaneously. Like, we certainly want to bring in more people who want to be engaged in the development of these products. But I think this summer really presents an opportunity to, solicit that help, but also to actually get into the data and the products with the folks that have presented on this call. So we're definitely recruiting, so to speak, right, Mary Beth?
Oh, yes.
Yeah.
I would say recruiting hard. Yeah. And so certainly the one-on-one connections that will be enabled by having the scientists' contact information. We encourage you to exploit that. But if we go through a more formal process, it enables me as a program manager, but also the other team members to hear maybe what the stakeholder document, what the requirements are, suggestions for data sets that maybe would be of interest to them as well. So if we do it on more of a, I don't want to say formal, but a more inclusive aspect rather than just emailing back and forth one-on-one, I think it could really benefit the larger coast as well as the larger Chesapeake Bay stakeholders. So that's what I'm proposing anyways. Maybe what we'll do is like a brief survey of the invited folks about how they best like to engage.
Hi, Nicole. This is Karina Nunes from BIMS. This is a great presentation. And again, as Julie said, this is very closely related to our work. And hopefully we can keep working with all of you to help you to validate the products and, refine also this existing product. So about outreach, also I was thinking that I'm part of the Chesapeake Bay Program Wetland Work Group and also participating in the coastal, the modeling work group. Those are meetings that are happening every other month and they're open. So if you're interested in presenting some of this to this audience, I think that would be great. And I can help you to coordinate and send you the information and make sure that your presentation is included in the agenda. If this is something that you think it's a good idea. I think it's okay, perfect.
Yeah, Karina, it's wetland and what was the other work group? Modeling?
Yeah, so there are two different work groups within the Chesapeake Bay program. One is the wetland work group and the other is the modeling work group.
Perfect, thank you so much.
And I'll send you an email later and just to make sure with information and then when are going to be the next meeting. And I think that is a great way and a great venue to receive feedback too.
Cersei also put something in the chat about York River Small Coastal Basin Roundtable meeting.
Yeah, the State of the York report was one of the early, let's just say, like beneficiaries potentially of some of the work of this pilot. I thought that we heard very early on that, and so Cersei, remind me, I think the last one was done over a decade ago, right? So
yeah, 2 decades ago.
Yeah.
We're getting conversations going. We have an outline now for the report, and the direction that we want to move in is becoming clearer. So right now may be a good opportunity to start jumping in on some of those conversations to ensure that the data and tools you're making available find their way into the report.
So that might be a good thing to pull me into potentially.
Okay.
Is so that then I can sort of facilitate the connections to the different products based on what's, you and I will both be armed and dangerous with all of our satellite knowledge.
Excellent. I will forward you some relevant emails and keep you in the loop.
Thank you. That sounds great.
Okay, so I just wanted to personally thank everybody for coming, especially those few of you who lasted all the way to the bitter end. We don't have any prizes, but I guess you're get an attaboy from the universe, maybe. Certainly from your Chesapeake Bay stakeholders who could benefit from CEOS Coast products. So yeah, I will say that Nicole and I remain willing to do outreach on CEOS Coast, certainly not this whole 3-hour ordeal. We'll give you a very high level 10-minute, 15-minute presentation, whatever is enabled, and we'll extend the olive branch for co-design, co-development to those new stakeholders as well. So that's it for me, other than I'll be in touch on Monday with all the promised connections. Nicole, did you want to say anything else, or anybody else on the call?
I was just looking, I recognize a lot of names, and I know we have registration information for folks, but I didn't recognize SRC. And I just wanted to know if that was a organization or a state office, or anyone, can anyone help me out?
My guess is it's somebody's initials.
Okay. Just didn't recognize. They sort of dropped something in the chat earlier, and I just wanted.
Sorry, I'm muted. This is it's my initials.
Oh, okay.
Mary Beth, you're correct. This is Samiria. How are you, Nicole? And how's
Oh,
everybody?
hey, Samir.
I'm not trying to be anonymous. I just was lazy at typing. That's all.
Oh, okay. That's a nice surprise. Samir's
Oh,
my
good.
boss.
Well, I'm sorry for calling you out, Samir. I just wanted to, I was
No,
like, there's
I'm
so
really
many
not.
acronyms in the Chesapeake that I was like, SRC, something Resource Council. Like, I was overthinking it. So thank you.
No. It's just yeah. And the comment on the stream gauges is because I know of a USGS project where they actually measure stream flow. Using these gauges, and the USGS has these things for years, and they could be used. I'm just curious if they could be actually.
Gotcha. Well, me and Nick are going to look into that. So thank you. All right. Thanks, Mary Beth. I don't have anything else.
Great. Well, then I think we'll end it here, and we hope everybody's going to have a Friday afternoon cocktail, or Steven Sager, if he's still on, he'll probably have a Saturday morning beer breakfast, maybe, where he is. Have a great weekend, and I'll talk to you on Monday via email. Thank you. Bye-bye.